Hi there, I'm Jamie, and for the past 10 weeks, I've been working with Dr. Sajib Mistry at Curtin University to develop resilient drone swarms using machine learning. Drones, which are also known as UAVs, that's unmanned aerial vehicles, are incredibly useful and interesting pieces of technology, which are becoming cheaper and more commonplace by the day, and so it is critical that we continue to improve their capabilities. In particular, my project focused on UAV swarms, that is, groups of UAVs dedicated to achieving some common goal. UAV swarms can be used for package delivery, search and rescue, and putting on light shows, and so much more. To be most effective, drone swarms should behave autonomously, that is, without any input from some central controller, as this will allow them to carry out their tasks without requiring constant human supervision. We looked at creating simulations of drones in order to improve their target navigation, formation control, and collision avoidance. This is sometimes challenging to do, as these goals can often be at odds with each other. For instance, it may be necessary for our drone swarm to break out of its orderly formation or move away from the destination in order to avoid an obstacle.
A number of different approaches exist for drone formation control, including virtual structure-based methods, where the drone swarm behaves as if it were one massive drone, behavioural-based approaches, where the drones switch between different behaviours when certain conditions are met. However, the most popular approach is perhaps a leader-follower approach, where one leader drone makes decisions and the other drones merely follow it.
In this example on screen, which we trained using the Topaz supercomputer, reinforcement learning is used to train drones to use a leader-follower approach. Drones are rewarded for moving closer to the goal, however only the leader is provided with the location of the goal. Hence, in order to maximise their reward, the leader will navigate to the target and the other drones will follow the leader. We also explored using the A-star algorithm for drone swarm pathfinding. The A-star algorithm is a well-known algorithm in graph theory for finding the shortest path between two nodes.
One classic example where the A-star algorithm is used is in the map software on your phone. If I ask for the quickest route from my house to the shops, I'm given a 15-minute drive. One way that the map software could have determined this is by testing every 14-minute drive starting at my house and determining that none of them take me to the shops. This could also be called Dijkstra's algorithm, and this is an example of how that works. So you can see that we've found this yellow shortest path between the house and the shops, but all these blue circles are the other paths that we tested on the way. Now this is a very inefficient way of doing this, because we can be fairly sure that driving in the opposite direction would not get me to the shops quicker. The A-star algorithm improves on this and explores less paths by assigning each intermediate point a potential in such a way that we start by exploring the points that bring us closer to our destination. When done right, A-star is guaranteed to find the shortest route, and much more efficiently.
We can apply this algorithm to our drone swarm by making each possible arrangement of drones a state, connected to each state which could be reached from it. In this way, the algorithm can find the shortest sequence of states which will take us from a starting position to our intended destination. On the screen behind me, you can see, for a single drone, us training it with the A-star algorithm, and then we can see it's found the optimal path. This is what it looks like. To extend this technique to drone swarms which need to maintain formations, we made it so that any move which takes you out of formation is more expensive, and so our swarm will explore moves that keep it in formation before looking at ones that break formation. This can be seen on the screen now, where we have, for swarms of up to 4 drones, various different formations, including horizontal lines, vertical lines, and clumps. In the immediate future, we wish to train our swarms to follow these optimal paths, using some form of machine learning. Ideally, we would train them on a number of different arrangements of obstacles, before setting them loose on a new set, to see if they're able to navigate autonomously, without spending time to determine an optimal path. We could also look at the effects of limiting their vision, or designating one drone as the leader and providing it with additional information.